Objective 5 deals with rational exponents. Now, a rational exponent is just an exponent that's written as a fraction. You're going to go over a lot of your old familiar rules that we probably need to practice a little bit more, but there is one new rule in this objective. A raised to the b over c power. This is the basic rule of how to turn something that's written in exponential form into radical form. Well, the first thing is you take a look at the denominator of the fraction. In this case, the denominator is c. It's the denominator of the fraction that indicates the index of the radical. So this would be the c root. In radical form, we know we're dealing with c as the index. And a is the base. Well, it's what stays inside. And the numerator of the fractional exponent is what the answer is raised to. Or the numerator can be on the inside, but the denominator of the fraction is always the index of the radical. The base is what goes inside, is what you're rooting, and then it can be taken to the b power on the inside. So either one of those, but that's the rule that we're going to be using over and over and over again in Objective 5. So my first series of examples, write each expression in radical form. So 25 raised to the 1/2 power. Well, the denominator shows us what type of radical it is. So in this case, it's square root. The denominator of the fraction is the index of the radical. Now I'm going to put that 2 there. You know you don't have to, but if you want to, you can. So square root 25 to the 1st power. And we know the square root of 25 is 5. The principal square root is 5. Now, 27 to the 2/3 power. The denominator is the index of the radical, so we're dealing with cube root. We're dealing with the cube root of 27 squared. So the cube root of 27, 3 times 3 times 3 is 27, so the cube root of 27 is 3. And then we have to square it, so our answer is 9. Now this one, 49 raised to the 1.5 power. We're going to want to put this into fractional form. So 1.5 is 3/2. So this would be 49 to the 3/2 power. And from here, that means this is the square root of 49. And then cube your answer. So that means the square root of 49 is 7, and cube your answer, and your answer is 343. Now the next problem, 4 raised to the negative 2.5. I'm going to keep this as 4 for a second. Now, 2.5 is the same as 5 over 2. So minus 5 over 2. So it's 4 raised to the negative 5/2 power. Now we're going to start reviewing one of those older rules. Anytime you have a negative power, the base, if it's up in the top right now, which it is, it drops down and it makes a fraction. So this would be 1 over 4. Now, once that negative has done its job, and its job is to throw that 4 down in the bottom. Now that it's done its job, it's not negative anymore. So my next step would be 1 over, now 4 to the 5 halves power is simply the square root of 4, and then take it to the 5th. Now the square root of 4 is 2, so this is 1 over 2 to the 5th power, and that's 1 over 32. Now, we could have taken a totally different approach with this. Let's rewrite this problem again as 4 raised to the negative 2.5 power. Now, what I could do, I still have to change it to 4 to the negative 5 halves power. But the first step I could do, instead of dropping the 4 down to the denominator like I did right here, I could go ahead and apply the new rule that we just learned. This is the square root of 4 raised to the negative 5 power. The denominator of the fraction became the index of the radical. So I took the square root of 4 and I raised it to the negative 5. Now we know the square root of 4 is 2. 2 to the negative 5 is the same thing as 1 over 2 to the 5th, and I still end up getting the same answer of 1 over 32. So for the next example, I'm taking x and I'm raising it to the negative 3/5 power, and we're trying to figure out what would be the radical version of this. Well, the denominator tells us what the index is, so this would definitely be the 5th root, and we would be taking the 5th root of x, and then we would be raising it to the negative 3rd power. So that would be my first step in this conversion. Now, the next step would be using the rule of a negative exponent. A negative exponent simply throws all of this down into the denominator of a fraction. So this would be 1 over the 5th root of x cubed. Or you could put the cube on the outside. 1 over the 5th root of x cubed. Now, 0 to the negative 7th. If you actually followed the rules of the negative exponent, a negative exponent tells you to take the base and throw it down to the bottom. So that would be 1 over 0 to the 7th. But that would be an undefined fraction because you can't have a 0 in the bottom, so undefined. Okay, now let's go the other way. Let's try to go the other way. Let's go from radical form to exponential form. In this problem, I'm taking the square root of 11x. If you want to put that 2 up there to help you, might not be a bad idea. Well, anything being square rooted is the same thing as it taking to the 1/2 power. So all it means is I've got 11x as my base, and I'm raising it to the 1/2 power, and that's it. Now on this one, the cube root of 36. Now, the additional instruction is we're going to use the lowest base possible. So cube root of, now we know 36 as a nicer number when we're dealing with exponents. 36 is 6 squared. So what that lets me do now is it lets me turn this from radical form to exponential form. 6 is the base, and the power that 6 is being raised to is the 2/3 power. Because remember, the index of the radical is the denominator of the fraction. So this 3 would go here, and that 2 would go there. And then this one is simply, I'm taking the 8th root of y and I'm raising it to the 5th power. That's the same thing as y raised to the 5/8 power. Now, we've already just reviewed one of the old exponent rules that you guys have already gone over, and that is the negative exponent. A raised to the negative b equals 1 over a to the b power. That negative sign really has one job, and that's to take this down into the denominator. Unless this was a fraction in the first place, then the negative would take what was down in the bottom up to the top. But we've got some really old rules we should probably go over also. When you multiply two things that have the same base, you add the exponents. So this would be a raised to the b plus c power. When you divide two exponential terms that have the same base, you subtract the exponents. So this would be a raised to the b minus c power. And then this one is what I call the power to the power rule. When you have an exponential term, such as a raised to the b power, and then you raise it to another power, you end up multiplying those two powers. It would be a raised to the bc power, times c. Now, for these rules right here, the first two rules, you have to have the same base. So I started off with one that is commonly missed. When the bases are variables, it's really easy to understand. But when the bases are actually numbers, it's really easy to multiply those two 3's because your eyes see 3 times 3. So you would think the base should be 9, but it's not. The rule is when you multiply two terms that have the same base, you keep the base. So in this case, it's 3, and you add the exponents. So 4 plus 9 would be 13. Now, here, the numbers aren't the bases. X is the base. 3 and 5 are the leading coefficients. So you actually do multiply them. 3 times 5 is 15. X to the 4th times x to the 9th would be x to the 13th power. So for this example, I'm following the multiplication rule. I'm multiplying two things that have the same base. So I know the base of my answer is x. But what do I do with the exponents? Well, the rule says I add the exponents. So it's 3/8 plus 4/5. So I've applied the algebraic rule of what do you do in this case. Now I just have to revert back to the elementary school way of adding two exponents to adding two fractions to see what the answer is. So 3/8 plus 4/5. I know I'm going to need common denominators, and I know that denominator is going to be 8 times 5, which is 40. This fraction has the 8, so the numerator needs to be multiplied by 5, which is 15. This fraction has the 5, so it needs to be multiplied by 8, so 8 times 4 is 32. So that gets me to the answer of, I know x is the base, and the exponent is 47 over 40. So there's the answer to that one. Now, moving on to the next one. We're going to use the rules of raising a power to a power, because when you look at this, forget about how ugly this looks right now. Just think of it as this ugly fraction is being raised to the 12th power. The numerator and the denominator, because of the placement of the fractions, the parentheses, the entire fraction is being raised to the 12th. So what I'm going to do is I'm going to give the 12th power to each of these. So this would be x to the 1/2 raised to the 12th over y to the -5/6 raised to the 12th. So you see right there how I gave the 12th power to both the numerator and the denominator. Well, now I'm going to use the rule of what do you do when you raise a power to a power? Well, you multiply. So this would be on the numerator, it would be x raised to the whatever 1/2 times 12 is. Well, over here, I'll just show you 1/2 times 12. It isn't 12 over 12, it's 12 over 1. So that would be 12 over 2. 1 times 12 is 12 over 2. And 12 over 2 is 6. So it would be x to the 6th power up here. Now down here, I'm going to do the same thing. When I raise a power to a power, I multiply. So really what I'm doing is I'm taking -5/6 and I'm multiplying it by 12 over 1. Now you can see some reducing that happens right here. That's 6 and that 12, 1 and 2. So this actually becomes -10. -5 times 2 is -10. So this is y to the -10. And now all I need to do is apply one more rule that says when I have a negative power, if what it's affecting is upstairs, it winds up going downstairs, but this one actually is downstairs already. It's in the denominator, so it needs to come up. So my final answer to this problem is x to the 6th, y to the 10th. Now, the last problem, I'm going to use the same idea. Everything in this problem is getting the 1/2 power. And I can distribute this 1/2 to both parts of this monomial term. So this would be 49 to the 1/2. And this would be x to the 10th to the 1/2. Down here, I'd have 36 to the 1/2. And I'd have y to the 16th raised to the 1/2. So if I start simplifying now, 49 to the 1/2 is the same thing as the square root of 49 to the 1st power, which is 7. X to the 10th to the 1/2. When I multiply 10 times 1/2, I get 10 over 2, which is 5. Now down here, 36 to the 1/2 is the same thing as the square root of 36, which is 6. And y to the 16th to the 1/2 is 16 times 1/2, which is 16 over 2, which is 8. And there's your answer to that problem. We're going to wrap it up with this one last problem. Now, the base looks like it's a trinomial term. There's a lot of people who would mistakenly think this is a trinomial term because it seems to have 3 parts in it. It has an integer, it has an exponential x, and it has an exponential y. Well, even though it has 3 parts, the fact that all of these parts are being held together with multiplication, and you don't see any pluses or minuses between these, it tells us this is a monomial term. So what we're going to be able to do is we're going to be able to distribute that 2/3 power to all 3 parts of this monomial term. Now I'm going to rewrite it out, so that would be 8 raised to the 2/3 power times x to the 3/4 raised to the 2/3 power times y to the 6th raised to the 2/3 power. So you can see what I did in step 1. I just gave everything the 2/3 power. Now I'm going to start simplifying using some of the old rules and some of the new rules. Like this one right here, this is the new rule. 8 to the 2/3 power is the same thing as the cube root of 8 squared. And this one, when you raise a power to a power, you multiply. So this would be x to the 3 times 2 is 6 over 12. 4 times 3 is 12. And this one would be 6 times 2/3. When you raise a power to a power, you multiply. So the base would be y, and the exponent would be 6 times 2 is 12 over 3. Now, we can reduce this one or simplify it. The cube root of 8 really is 2. So this would be 2 squared. The next part of the problem, 6 over 12 is 1/2. And then this part of the problem, 12 over 3 is 4. So we can clean this problem up and finally write the most simplified part of the answer as 2 squared, which is 4, x to the 1/2 y to the 4th. And that's it.